So in this video, we're going to look at how you can use a Caesar cipher to encrypt a message. The basic strategy is that we take the plain text message. With the cipher is that we shift everything, all the letters of the alphabet get shifted along by a certain number of places. The number of places is the key. So let's imagine we use a key of 3. What that means, if we want to write down the letter C, instead of writing a C down, we move 3 places along the alphabet and we end up with the letter F. And we write down the letter F instead of the letter C. We'll see how we do that in a moment. Once you've taken your plain text and passed it through your cipher with your key, you get cipher text, which is the muddled up text that makes no sense. Now over here, I've got a little piece of text that I want to encrypt in cipher. They both mean the same thing. The cat's out on the mat. And what we're going to do is we're going to look at how we do that. And we're going to use a key of 3. In other words, every letter in our message is going to get shifted along 3 places. So I've highlighted this row over here in green. This area on the left here is called a crib, and it's simply a tool that we use to help us encrypt or decrypt messages. And this one's for the Caesar cipher. So I've written the letters of the alphabet along, and then on each of the rows underneath I've shifted the letters back by a certain number of places. So this, if I read from the top downwards, it's as though the letters moved on. So the letter F here, I move it one place, I get G, then I get H, I, J, K, and so on. The problem, of course, happens when you shift a letter along a lot of places. They kind of fall off the end of the alphabet, and in that case you put them back on at the start, which is why we can see the letters A, B and C and so on appearing in this area down here. Anyway, let's get started. Let's decrypt this first word, the word the. So we find the word letter T in the top row, here it is, and we move down 3 places. So we shift the letter along 3 places, and when you take a T and move it 3 places along the alphabet, you get the letter W. If we take the letter H over here and we shift it 3 places, we get the letter K. And then over here, if we take the letter E and we move along 3 places, 1, 2, 3, we get the letter H. And you can see my crib shows that in the green row right there. So if you know your alphabet, and then I want my letter F, my cipher letter is F. F is right there, so unsurprisingly that's the letter C. The letter D here, there we go. That becomes an A, and the letter W. If I go along my row here and I find that, I find the letter T. And there you go, I've got back to the cat. Now, you can also do this, of course, if you just got a pencil and a piece of paper. If we knew the cipher letter was W and everything's been shifted back 3 places, we just count 3 places back in the alphabet. 1, 2, 3, and we get the letter T. If we take the letter H, we go back 3 places. 1, 2, 3, we get the letter E, and so on. So it's fairly easy to encipher and decipher messages using a Caesar cipher. However, it's not the strongest cipher in the world, and we do need to be a little bit careful in its use. One of the major problems it has is that each letter in the alphabet always gets translated into another letter, and it's always the same letter, it never varies. And this means if you know a little bit about English and you're trying to work out what a message has been, what the shift is that's been used to encipher this message using a Caesar cipher, it's fairly straightforward. For example, there are only 2 words that are used in the English language that are 1-letter word, the letter I and the letter A, or the word A as in a cat, and the I as in I am. So if you know a little bit about English, and the message like this one here has got spaces in it that show the words, then you can use your knowledge of English to try and work out what the key is by process of deduction. But equally, you can simply try and decrypt this using a key of 1, then try and decrypt it using a key of 2, then try and decrypt it using a key of 3. That's called a brute force attack. It's quite slow, but it will eventually get there, because of course the maximum number of attempts you'll need to decrypt the message is 25, because we've got a relatively small number of letters in the alphabet. And on a modern computer, you could do that in about, I don't know, a 10,000th of a second. So it's not a very secure cipher in the modern world.